I'd like to give an overview of Chapter 2, Newtonian Mechanics, by just going quickly through Newton's three laws of motion. And so there is a first law that says that, and I'll say it a little bit differently than the book, that if the net force, remember force is a vector, is equal to 0 newtons, then a body which has net force on it will continue at constant velocity. Okay, so now as you know, constant velocity means that the acceleration is equal to 0. And constant velocity is, units for that are meters per second. Units for acceleration are meters per second per second. Okay, so F net is the vector sum of all the forces acting on a body. And so just to give you a simple example, let's say you had a mass m sitting on a table, just sitting on a table. It's not going anywhere. Its velocity is not changing. And the net forces acting on it are 0. There are two forces, and we'll talk a lot more about this later. There will be a force of mg, which is the force of the Earth on this mass m, and then there will be an upward force equal and opposite to the downward force. Draw that a little bit longer here so I make the vectors the same. Let me fix this. Something like that. And this, as we will see, this is the normal force, and this is the force of the table acting upward on m. These two vectors are equal and opposite. F net is equal to 0, and therefore this does not change its velocity. And since it's at rest, it will remain at rest. Okay, Newton number 2 is the one we'll use quite a bit for computational purposes. And basically what that says is that if you have some vector sum of forces acting on a mass m, that the mass m will accelerate. And it will have an acceleration equal to the net force divided by the mass of the object. Okay, real simple example of that is free fall. And so in free fall, so this is an example of Newton number 2. In free fall, we have a mass m that has only one force acting on it, m times g. That's the force of the Earth acting on m. And so the acceleration of that mass is, by Newton number 2, given by the net force mg over m, which is g. And therefore the mass accelerates downward with an acceleration of g, which is 9.8 meters per second, or typically in class we use 10 meters per second. Okay, that Newton number 3 says that that forces always come in pairs. And so it says a little bit more than that too. It says that every force acting on an object has an agent. And so you always have the force of the agent acting on the object. So for example, here's a wall And here is a hand pushing on the wall. And the agent for this force is the hand. And the object it's acting on is the wall. The wall is off to the right here. Newton number 3 says that if there is a force of the hand acting on the wall, then there is an opposite, equal and opposite force of the wall acting on the hand. And so if this is the hand right here, then there is a force of equal magnitude in opposite direction. And this is, I should put little vector things on top of here, force of the wall acting on the hand that's pushing it. So what Newton number 3 says is forces come in pairs. There's always an agent and an object, and they are related to each other. So if I switch the object and the agent, as I did in this example here, they're equal in magnitude and opposite direction. And so the words that are usually used are, for every action, read this on the left, there is an equal and opposite, that's where the minus sign comes from, reaction. In some ways, Newton number 3 is the hardest one to understand, but we'll be using all three of these a lot. The number 2 is going to be the one probably we use the most, but we will use them all.